today's lecture. My name is Noah Scheinbaum. Today's topic is on polynomial multiplication. Now, before we get started, I'd like to just remind everyone that you can rewatch this video whenever you need review on the subject material. Okay, so to start off, let's review examples of what are and aren't polynomials. So our first example is negative 3x squared plus 5x minus 7. Is this a polynomial? Well, yes. In fact, it's a textbook, pretty much, quadratic equation. You got a term times a variable squared plus a term times a variable plus or minus a constant. So this is a quadratic polynomial, quadratic referring to a degree of 2. How about this one, 3xy plus 19y to the 4th power? Is this a polynomial? Well, there's two variables. Does that matter? Actually, no, it does not. It is still a polynomial. A polynomial can have two different variables. It can have 4 different variables, just one variable. It could have 117 variables. I almost guarantee that you'll never see that in mathematics, but it still technically can be a polynomial. That does not interfere with the definition. How about this? 3 over x. Well, the main issue here is that you have a variable in the denominator. And since you have a variable in the denominator, no, this is not a polynomial. Since the expression divides by a variable, this is not a polynomial. How about the number 9? Is the number 9 a polynomial? Well, at first glance, you might think, well, there's no variables. So how could this be a polynomial? Well, 9, recall, is equivalent to 9x to the 0 power, or 9y to the 0 power, 9 times any variable to the 0 power, because any variable to the 0 power is 1, so any constant is still just a polynomial. Yes. How about the square root of x plus 2? Well, the square root makes this not a polynomial. You cannot have a variable under the square root. You can have coefficients be under a square root. That does not interfere with it being a polynomial. In fact, we'll see an example of that later. But since the variable is under a root, this is not a polynomial. How about 3 to the x plus x? Well, we have an exponent that is a variable, so this is actually an exponential function. And by definition, exponential functions cannot be polynomials. So since the exponent contains a variable, this is not a polynomial and instead an exponential function. How about square root of 3 times x plus 7? Well, as we said before, if there is a square root over the x, then it cannot be a polynomial. But since this is just the square root over the coefficient, right, this is a linear function. This is actually a line with a slope of square root of 3 and a y-intercept of 7, and all linear functions are polynomials. Although there is a square root, it is not applied to a variable, instead to the coefficient. So this is a polynomial. And then our last one, x plus 3 minus 3x to the negative 2. This is not a polynomial for the same reason that 3 over x is not a polynomial. You cannot have any variables in the denominator, and recall that 3x to the negative 2 is the same as 3 over x squared. So you can't have a negative number in the exponent. That makes it not a polynomial. Okay, great. So now that we've reviewed examples of what is and is not a polynomial, let's review how to multiply them. So some key vocabulary that we'd need to know before we get into this. A monomial is a polynomial with a single term. Examples are y squared, 3xy, 17x, pi, 4.7. All of these are monomials because there's no plus or minus term separating the variables. And a binomial is a polynomial with two terms. For example, x plus 3, 2x plus y, and z squared plus 6. Following the same naming conventions, a trinomial is a polynomial with 3 terms. An example of this is 7/2 y to the 16th plus 27x plus 1. We've got 3 different variables, groups of variables that are being added up or subtracted. This was a minus sign, this could still be a polynomial. This was a minus sign, this could still be a polynomial. Plus or minus does not interfere with it being a definition of a polynomial. And then the degree is the greatest exponent of the polynomial. So for a constant, the degree is 0. Because, as I mentioned before, you can treat this as 4.7 times x to the 0 power. For 17x, the degree is 1, right? Because this is 17 times x to the first power. And for this one down here, the degree is 16. because y to the 16th power makes this have a degree of 16. Okay, great. So, multiplying polynomials. When multiplying polynomials, we have to use a property in mathematics that you likely have already learned but have not applied much to this point. That's the distributive property. Recall that the distributive property states the following. So this may look like a lot, but basically what it's saying is if you have a sum, right? If you have a sum and then you're multiplying that by some number, it's the same as taking the individual components of the number, multiplying it by that, and then adding that up. So k times the quantity a plus b equals ka plus kb, and same thing if you have 3 different addends that you're adding up, or however many. Does not matter. For example, if you want to do 4 times 3 plus 5, well, you could just add this up, right, and do 4 times 8, that's 32. Or you could use this distributive property to do 4 times 3 plus 4 times 5, which is 12 plus 20, which is 32. They'll give you the same answer regardless. Now, with this example in particular, the distributive property is not necessarily that useful, but for multiplying polynomials, it is. Here's a good example. 4x squared times 7x cubed plus 9x plus 3. So when you're multiplying a polynomial by a monomial, we need to make absolutely no adjustment to the distributive property. So let's just distribute this 4x squared term out to every term in the trinomial. So if we distribute this out, it's the same as 4x squared times 7x cubed plus 4x squared times 9x plus 4x squared times 3. If we multiply this, we'll get 28x to the 5th. If we multiply this, we'll get 36x cubed. And if we multiply this, we'll get 12x squared. Right? So while at first this may look very complicated, it's really a matter of making sure you know when and where to apply distributive property to make the problem a lot simpler. Now, keep in mind that applying the distributive property like this only works when you are multiplying by a monomial. If you're multiplying by a binomial or a trinomial or something more, you'll have to make a minor adjustment to the distributive property. Okay, so here's our second example. We're multiplying 2 binomials together, 2x plus 4 times x plus 7. When multiplying polynomials by something other than a monomial, the distributive property has to be modified slightly. Instead of distributing only one term, we are now distributing 2. So if we distribute this out, this first term, 2x plus 4, out to the x plus 7, we get 2x times x plus 7 equals 4 times x plus 7. This is just an adaptation of the distributive property. It's saying the same thing. Now, we can multiply these monomials individually using the distributive property and then add it up. Okay, so this one will get us 2x times x plus 2x times 7, which gives us 2x squared plus 14x. Following the same logic for this one, we'd get 4x plus 4 times 7, which gives us 4x plus 28. Now adding these two up, because we had to add these here, adding these two up, we'd get 2x squared plus 14x plus 4x plus 28. These like terms combine, and we get 2x squared plus 18x plus 28. Now, your teacher may use the acronym FOIL when describing multiplying 2 binomials. It stands for first, outer, inner, last. It's an easy way to remember to distribute properly because you multiply the first terms together, then the outer terms, then the inner terms, and then the last terms, and then add the results up. For example, with the previous problem, right, our first terms are 2x and x, our outer terms are 2x and 7, our inner terms are 4 and x, and our last terms are 4 and 7. Now, keep in mind, this is just the same math as this, right? This here will get us our first and our outer terms. This here will get us our inner and last terms, but it's just really a different way of writing it. Okay, and then when we add this up, right, it will get us the same result regardless. If we added this up, we'd get 2x squared plus 14x plus 4x plus 28, which is 2x squared plus 18x plus 28. And while this trick is useful, especially for remembering to distribute property, we cannot fall back on it because it only can be applied when multiplying two binomials. It's good to know the math behind it so that we can apply the distributive property to other problems. Like, for example, this final one, where we are multiplying a trinomial by a binomial. And there are two different variables here. We have x and y, but that does not make the actual math any more complicated. It's still the same distributive property. Okay, so to get started, let's distribute out this trinomial, right? Instead of having this mess, we can distribute out x squared plus 7y squared plus 11 to this binomial and get x squared times 7x plus y plus 7y squared times 7x plus y plus 11 times 7x plus y, right? Just the distributive property adapted. Now when we multiply these out, x squared times 7x plus y equals x squared times 7x plus x squared times y. This here will become 7 times x squared times x, which is 7x cubed, and then x squared times y can't be simplified, so that's just x squared y. All right, and then the second part right here, 7y squared times 7x plus y, that becomes 7y squared times 7x plus 7y squared times y. The 7's here multiply, so you get 49 times x times y squared. And then over here you get 7 times y squared times y, which becomes 7y cubed. So over here you get 49xy squared plus 7y cubed. The main difficulty with problems like this are making sure that you keep your terms in order and you're simplifying correctly. And then for the final part of this, 11 times 7x plus y is just 11 times 7x plus 11 times y, which gives you 77x plus 11y. Now, to get the final answer, we have to add these three up, right? And since there are no like terms, x cubed, x squared y, xy squared, y cubed, x and y are all separate terms, we can't simplify anything, so we have to just write it as is. 7x cubed plus x squared y plus 49xy squared plus 7y cubed plus 77x plus 11y. Okay. Thank you so much for watching. You can rewatch this video whenever you need review on the subject, like I said before. Have a great day.